So, my dear friends, in the last class, till the last session, we were doing permutations, right? We have completed all possibilities related to permutations. Now, in this session, let's go ahead and let's try to complete everything related to combinations, right? Now, in permutations, what we have done arrangements. Now, what we are doing in combination, we are doing selections in combinations. In permutations, we have done arrangements. In combinations, we are doing selections. In permutations, order was important, but in combination, order is not important. Like in this case, my dear friends, either you write ABC or you write BCA or you write CAB, anything, everything will remain same. There is no change. Okay. Like say, for example, we are having three people, A, B, and C. Okay. I need to distribute them 3 awards. First award, second prize, third prize, or 3 prizes. First prize is 10,000, second prize is 7,000, third prize is 3,000. Okay. Here, each and every prize is different, right? How will I distribute 3 prizes to 3 people? I'll distribute in 3p3 ways. Okay. 3p3, which will be equals to 3 factorial, that is equal to 6. Now, I'm having 3 jobs. First job, second job, and third job. 3 works I'm having. First job salary is 10,000, second job salary is 10,000, third job salary is 10,000. I need to distribute to 3 people, A, B, and C. So first job, second job, third job. First job I have given to A, second job I have given to B, third job I have given to C. Who will be the most happiest person among all the 3? Sir, obviously, sir, all the 3 will be happiest person. First job I have given to B, second job I have given to C, third job I have given to A. Who will be the happiest person? Obviously, sir, all the people will be the happiest person. Or I am giving in terms of CBA or CAB. Even in this case, all people will be happiest person, sir. There is no change in the way you give them jobs. Either you give them in this manner, in this manner, in this manner, or in this manner. Nobody cares because order is not important. Okay, first job you give to B, second job you give to A, third job you give to C, or first job to C, second job to A. Given any order, nothing matters here. Okay. So in this case, my dear friends, when you're giving the jobs to these 3 people, nothing matters. But here, when you're giving awards to these people, if you give first job to A, second job to B, and third job to C, A will be the most happiest person. First job to B, second job to C, and third job to A, C will be the most happiest person. Means in this case, the order in which you give them jobs, so the order in which you give them prizes matters. But in this case, order in which you give them jobs do not matter. So since order matters here, we are using permutation. Since order doesn't matter here, we are using combination. Like you are arranging numbers, letters, okay, seating arrangements. In all these cases, we have permutations, my dear friends. You are doing selection. You are doing committee formation. Or you are doing geometrical applications. What are these geometrical applications? We'll see at the end. In all these cases, combinations matter, my dear friends. That is, order is not important. You are forming a committee, order is not important. You are inviting somebody for the marriage, order is not important unless and until you invite them. 10 people are there, you are inviting them marriage, you are inviting them for marriage. You invite them in any order, nobody cares. Because order is not important over that. Okay. So I hope the concept of combinations is clear, my dear friends. Now, in permutations, the number of ways of selecting R things from N things is NPR ways. The same way, the number of ways of selecting R things from n things is NCR base. Now, what is this NCR? NCR will be NPR by R factorial. That is nothing but n multiplied backwards R times whole divided by R factorial. Okay. Like say for example, I'm asking what is 12C4. What will be 12C4? N multiplied backwards R times 12 into 11 into 10 into 9 divided by 4 factorial. Let's check. 12 into 11 into 10 into 9, 11,880 whole divided by 24 is equals to 495. I'm asking, sir, what is 12C3? 12 multiplied backwards 3 times. 12 into 11 into 10 by 3 factorial. How much will get? 12 into 11 into 10 divided by 3 factorial is 6. 220. Okay. So I hope the concept is clear how to compute NCR. Simply n multiplied backwards R times. I'm having 7C2. 7 into 6 by 2 factorial. I'm having 9C3. 9 multiplied backwards 3 times. 9 into 8 into 7 by 3 factorial. I'm asking 11C3. 11 into 10 into 9 by 3 factorial. Okay. I'm asking what is 8C4. 8 into 7 into 6 into 5 whole divided by 4 factorial. This is how you will calculate, my dear friends. Now, there is one beautiful thing here what you need to understand. Now, we got 12C3 as 220, right? Even if you calculate 12C9 also, you will get 220 only. You can check it. 12C3 and 12C9 both will be equals to 220. Or else you can check 11C3. What is 11C3? 11 into 10 into 9 divided by 6, which is 165. You can even calculate 11C8. 11 into 10 into 9 into 8 into 7 into 6 into 5. 1, 2, 3, 4, 5, 6, 7, 8. Whole divided by 8 factorial. Even in this case, you will get 165 itself. You can check. Okay. So either you calculate for 11C3 or either you calculate for 11C8. Answer is same, my dear friends. Okay. So one thing what I want to say here, there's a property which I want to develop. The property will be NCR is equals to NCN minus R. This is the property which I wish to develop. NCR is equals to NCN minus R. That's the reason 12C3 and 12C9 will be same. 11C3 and 11C8 will be same. I want 9C8 will be equals to 9C9 minus 8, which is 9C1. So now what is 9C1? 9C1 is 9. NC1 and NCN minus 1 both will be equals to N. Like 9C8, 9. 11C10, 11. 11C10, 11. 99C98, 99. 101C100, 101. So NC1 and NCN minus 1 both will be equals to N. NCR will be equals to NCN minus R. The same way, my dear friends, NC0 will be equals to NCN, which will be equals to 1. There's no point in calculating here. I'm saying what is 9C9? 1. I'm saying what is 100C100? 1. How will you select 100 people from 100 people? Only one way. 1. You select in any order, it doesn't matter. I'm telling 8C8, 1. 4C4, 1. Okay. Let's see here. Number of ways of selecting R things from N things, NCR, NPR by R factorial, or this is the formula. N multiplied backwards R times divided by R factorial. I said you NC0 will be equals to NCN is equals to 1. Next NC1 will be equals to N and NCN minus 1 will also be equals to N. Next NC2 N into N minus 1 by 2. NC3 N into N minus 1 into N minus 2 by 3 factorial. Now, what is NCR, my dear friends? NCR is NPR by R factorial. Let's do cross multiplication. R factorial is equals to NPR by NCR. R factorial by NPR by NCR. Next, NCR will be equals to NCN minus R. We have understood this point also. Next, if NCX is equals to NCY, N will be equals to X plus Y or X will be equals to Y. Now see here, my dear friends. If you see here, 12C3 and 12C9 both are same, I said, right? Now what is 9 plus 3? 12. Next, I said 11C8 and 11C3 both are same. What is 8 plus 3? 11. So property is if NCX is equals to NCY, either these both will remain same or N will be equals to X plus Y. Okay. Like say for example, I'm telling 18CR is equals to 18CR plus 2. I'm asking what is RC5? Now if NCX is equals to NCY, N will be equals to X plus Y, R plus 2. Take to the left side. 16 is equals to 2R. 16 divided by 2, which is equals to 8, which is equals to R. What is RC5? 8C5. Let's check 8C5. 8C5 will be equals to 8C3, right? 8 into 7 into 6 divided by 3 factorial, which is 56. Okay. Simple point. I hope this point is clear. Once calculate and tell me this one. NC10 is equals to NC14. Can you tell me what is 25CN? NC10 is equals to NC14, then what is 25CN? Yes, Vaishnavi, perfect. Yogita, perfect. Perfect, Yogita. So answer is simple. NC10 is equals to NC14, right? So N will be equals to 10 plus 14, which is equals to 24. So 25 C24, which is equals to 25. Okay. Now NCN minus 1 will be equals to N, right? The same property. Next. Now what is this one? 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5. How much will be? 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5. Let's check how much it will be. 5C0 is 1. 5C1 is 5. 5C2. 5 into 4 by 2. 10. 5C3 will be 10. 5C4 will be 5. 5C5 will be 1. 1 plus 5 plus 10 plus 10 plus 5 plus 1. It is 32. So can you see, my dear friends, 5C0 plus 5C1 plus 5C2 plus 5C3 so on till 5C5 is 32. Yes. That's nothing but it is simply equals to 2 power n. Okay. Like NC0 plus NC1 plus NC2 plus NC3. So on till NCN will be equals to 2 power n. That 2 power n answers. Or else I can say the entire final resultant is 2 power n. Okay. Next. If I send 0 to right side, NC1 plus NC2 plus NC3, so on till NCN will be equals to 2 power n minus 1. Okay. Like say for example, I am telling you are having 8 friends. The number of ways you can invite one or more. How many ways are there for you to invite one or more? From 8 friends, either I can invite one friend of my choice, or 2 friends, or 3 friends, or 4 friends, or 5 friends, or 6 friends, or 7 friends, or 8 friends. Either I can invite one friend or I can invite all 8 friends. This is my choice. 8 friends are there, the number of possibilities of inviting one or more for the party will simply be 2 power 8 minus 1. Why I'm doing minus 1? Because there is no NC0, right? That's the reason I'm doing minus 1. So 512 minus 1, 507. Okay. I'm telling you are having 4 currency notes. In how many ways you can donate one or more? Or in how many ways you can donate at least one? So when you will be using this formula, whenever he is saying one or more, or when he is telling at least one, in these cases you will be using this formula. 4 currency notes, you have to donate one or more. So 4C1 plus 4C2 plus 4C3 plus 4C4. So 2 power 4 minus 1. 16 minus 1, which is equals to 15. So there are 15 ways to donate one or more. Okay. So I hope all these points are clear. 2 power 8 is 256, sorry. 2 power 9 is 512, 2 power 10 is 1024. Okay. 256. Yeah. Minus 1, so 255. So NC0 plus NC1 plus NC2. Next, number of ways of selecting at least one thing from n things. Number of ways of selecting at least one thing from n things. 2 power n minus 1. Number of ways of failing in a test with n subjects. 2 power n minus 1. Or NC1 plus NC2 plus NC3 so on till NCN is also 2 power n minus 1. Now what is this? He'll ask you in the examination. A test contains 5 subjects. He says a test contains 5 subjects. In how many ways you can fail in that test? It will be 2 power 5 minus 1, 32 minus 1, 31 ways. If a test has 5 subjects, the number of ways of failing in that test is 31 ways. Okay. Now, fifth point is important. We'll come back to this. Now, see this example, my dear friends. There is one example where we'll try to get the maximum possibilities in that example. Okay. See here. I'm telling example number 1. I'm having 10 people. In how many ways I can form a committee of 6 people. 10 people are there. In how many ways I can form a committee of 6 people? How it will be? From 10 people, I need to select 6 people. 10C6 ways. I need to form a committee of 4 people. How it will be? 10C4 ways. Okay. I need to form a committee of 7 people so that Mr. X is not included. I'm telling I need to form a committee of 7 people so that Mr. X is not included. Total 10 people are there. From that, I need to select 1 person, 7 persons. But I'm telling Mr. X is not included. So how many persons are left now? Only 9 people are left. Sir. So 9C7 ways. 1 person is not included. So I'll reduce that 1 person from 10 persons. Next, I'm telling form a committee of 7 people so that Mr. Y is included. Not included, or I can say excluded. I am telling Mr. Y is included. Okay. Now, how will you do if Mr. Y is included? It is simple. From 10 people, I need to select 7 people. 1 person was already selected. From 10 people, I need to select 7 people. 1 person I have already included in the committee. Now, how many people are left? How many positions are left in committee when one position is already occupied? 6 people. How many people are left? 9 people are left. I need to select 6 people from 9 people. 9C6 wins. Okay. So I hope third and fourth point is clear. Third point, Mr. X is not included. So n-1 CR. Fourth one, Mr. Y is included. So here it is n-1 CR ways. Here it is n-1 CR-1 ways. Okay. Next. Next example, it's a good example. I'm telling there are total 7 men and 6 women. 7 men and 6 women is there. First case, form committee of 5 people with 3 men and 2 women. How will I form a committee of 5 people with 3 men and 2 women? First, from 7 men, I need to select 3 men. And from 6 women, I'll select 2 women. So answer is 7C3 into 6C2 ways. Next. I'm telling form committee of 6 people with 4 men and 2 women. Again, how it will be? 7C4 into 6C2 ways. Okay. Next. I'm telling form a committee of 5 people with at least 1 man. I'm telling form a committee of 5 people with at least 1 man. Means how will you interpret this? You'll interpret as I can have 1 man or 4 women. So I can have 1 man and 4 women. Or I can have 2 men and 3 women, or I can have 3 men and 2 women, or I can have 4 men and 1 woman, or I can have 5 men and 0. That's what I'm done. Form a committee of 5 people with at least 1 man. So 1, 4, 2, 3, 3, 2, 4, 1, and 5, 0. So how will I have a committee of 1 man? It will be 7C1 into 6C4, 7C2 into 6C3, 7C3 into 6C2, 7C4 into 6C1, and 7C5 into 6C0. You'll simply add all these things. Okay, because connecting word is or, right? You'll be adding all these things. So then we can calculate the 6 into 6C4 is 6C2, 6 into 5 divided by 2 into 7, 105. 6 into 5 into 4 divided by 3, 40, 62, 15, 6, 1. 7C2, 7 into 6 by 2 is 21 into 40 into 6 into 5 divided by 3, that is 70 into 15. 7C4 is 21, 7C5 is 7C4 is 70. 7C5 is 21 into 1. You can simply go ahead and add all these things. Okay. So I hope the third point is clear. Form a committee of 5 people with at least 1 man. I'll give you 2 cases. Try to calculate them and give me an answer. Form a committee of 5 people with at least 2 women. Next. Form a committee of 5 people with at most 3 men. Solve these two. At most means maximum. Solve these two and tell me the answer. Let me see who we can give. Both the final answer you tell. Okay. You can try this question as well. A paper with 10 questions. Six in group 1, 4 in group 2. Answer any 5 questions. Selecting minimum 2 from each group. Think and solve these 3 and tell me the answer. So form a committee of 5 people with at least 2 women, he telling. So what can I do? Can I select 3 men and 2 women? Yes. Can I select 2 men and 3 women? Yes. Can I select 1 man and 4 women? Yes, sir, you can. Can I select 0 men and 5 women? Yes. He's telling form a committee of 5 people, so as to include at least 2 women. So there can be 2 women, 3 women, 4 women, or 5 women. Anything is fine. Yeah. Now, how will you select 3 men? How many men we have? 7 men we have, right? 7C3 into 6C2. 7C2 into 6C3. 7C1 into 6C4. 7C0 into 6C5. Now 7C3, I hope already we calculated 70 into 15. 7C2 we have already calculated. So you got 21 into 6C3 also we have calculated, which is equals to 40. 7C1 70 into 6C4 is equals to 15. 7C0 is 1, 6C5 is 6. Let's calculate how much we'll get. 70 into 15. 21 into 40, 70 into 15, 1 into 6. 2946. One second, you get the same answer. So you took reverse. 7 women and 6 men. So what about you, Geeta and Vaishnavi? You got the same answer? You got 1056. You both got 1056. I got 2946. Anything wrong I did, or 63 is 20? Yeah, 63 is 20. Then here also 63 is 20 then. It's not 40. It's 20. 20. Let's check. 17 to 15 m plus 21 into 20 m plus 17 to 15 m plus 1 into 6 m plus MRC. I got 2526 now. And 7C3 is also not 70. 7C3 is 35. Here also you didn't say here 7C3 is 35, not 70. So 35 into 15 m plus 21 into 20 m plus 7C1 is 7, sir, not 70. Oh, so many blunders we have done in one question. 35 into 15 m plus 21 into 20 m plus 15 m plus 1 into 6 m plus MRC. So 1056 is the correct answer. So what you got is correct, 1056. Okay. Just don't make blunders like me in the exam. 7C1 I wrote it as 70. Now form a committee of 5 people with at most 3 men. Means maximum 3 men. Means I can have 3 men and 2 women. I can have 2 men and 3 women. 1 man and 4 women. 0 men and 5 women. Okay. 3210, 2345. Both are same. Answer is 1056 itself. Okay. Next. A paper with 10 questions, 6 in group 1 and 4 in group 2. Answer any 5 questions selecting minimum 2 from each group. Okay. Minimum 2 from each group. I'm having 2 groups. Group 1 and group 2. Okay. He's asking select minimum 2, 1. Yes, Gita will check. Minimum 2 from each group. Can I select 2 from group 1 and 3 from group 2? Yes, sir, you can. Can I select 3 from group 1 and 2 from group 2? Yes, sir, you can. Can I select 4 and 1? No. Because he's telling minimum 2 you have to select. Now, 6C2 into 4C3. 6C3 into 4C2. Now, how much is 6C2? 15. 4C3? 4. 15 into 4, we have 60. 63, 6 into 5 into 4 divided by 6, we have 20. 4C2, 4 into 3 divided by 2, that is 6. 120. So total will be 180. Okay. So I hope it's clear, everybody. Simple one, there is nothing much difficulty here. 1 minute. So I hope all the 3 questions are fine. Yes, sir, all the 3 questions are. Now, there is one question which I want to solve. That's very good sum. Many people, they find a little difficult in that question, but yeah, let's try to solve that. It's axiometrical sum itself, and there is one previous year questions which you will solve now after this sum. I'm saying a committee of 3 ladies and 4 gents is to be formed from 8 ladies and 7 gents. Mr. X refuses to join the committee where Mrs. Y is member. That's a given question. See here what is telling. There are total 8 ladies and 7 gents. Yeah. From 8 ladies, I need to select 3 ladies. From 7 gents, I need to select 4 gents. That's a given question. From 7 gents, I need to select 4 gents. But the condition is Mr. X refuses to serve in a committee in which Mr. Y is the member. Okay, that's a given question. Now see, how will you solve this? See, direct solving is not possible for this question. So what we'll do indirect solving for this. So how will you do indirect solving? Simple. He is telling you need to select 3 ladies from 8 ladies. You need to select 4 gents from 7 gents. And he's telling Mr. X refuses to join the committee in which Mr. Y is the member. So I need to solve 2 things here. What I will do is that total possibilities minus Mr. X and Mrs. Y together. I am doing total possibilities minus Mr. X and Mr. Y together. So I'll get Mr. X and Mrs. Y not being together. Yeah, total possibilities minus impossibility. That's fine, Geeta. Okay. Total possibilities minus Mr. X and Mr. Y together. I'll get Mr. X and Mr. Y not being together. Now, what are total possibilities? How will you select 3 ladies from 8 ladies? 8C3. How will you select 4 gents from 7 gents? 7C4. Now, I'll see Mr. X and Mrs. Y together in committee. Now, see, how will I do this? From 8 ladies, I need to select 3 ladies. Now, be careful, I'm doing this part. Mr. X and Mrs. Y together in the committee I'm doing. Okay. Now, how will you select 3 ladies from 8 ladies? I'll select in 8C3. 4 ladies from 7 gents, 7C4. Now, I'm telling Mr. X and Mrs. Y together in the committee. From 8 ladies, I need to select 3 ladies. First, what I'll do, I'll tell Mrs. Y, please go and sit in the committee. 3 chairs are there. 8 people are there. Okay. 3 chairs are there. 8 people are there. I'll tell Mrs. Y, please go and occupy your chair. So how many people are left? 7 people are left. How many chairs are left? 2 chairs are left. How will you give these 2 chairs to these 7 people? 7C2. Okay. Next. 7 gents are there. 4 seats are there. I'm telling Mr. Y will be there in the committee at any cost. Sorry, Mr. X will be there in the committee at any cost. I'm telling Mr. X, please go and sit in your chair. So how many are left? 6 are left. How many chairs are left? 3 are left. 6C3. So what is 8C3? 8 into 7 into 6 divided by 3 factorial, which is 56. 7C4, 7 into 6 into 5 divided by 3 factorial, 70. Minus 7C2, 7 into 6 by 2, 21. 6C3, 6 into 5 into 4 divided by 6, that is 20. So 56 into 70, 3920, 21 into 20, 420, which is equals to 3000. 3500 we got. 8 into 7 into 6 divided by 6, 56. 7 into 6 into 5 into 4 divided by 20. This is 35, not 70. Hmm. 56 into 35, 1960. 1960 minus 420. Which is equals to 1540. Okay. Simple. The answer is 1540. So the number of ways of forming a committee in which Mr. X refuses to join a committee in which Mr. Y is a member is 491540. I hope the concept is fine, everybody. Simple one. There's nothing much difficulty. Now, if we take one previous year question, that was a very good question. I hope I'll find that. It's not there here. Give me 1 minute. It's getting downloaded. Till it gets downloaded, we'll do few more questions. Example. Now, see this point, my dear friends. 6th point and 5th point. First, let's do 6th point and 5th point. It's getting loaded. 1 minute. Internet connection is unstable. Let's do the 6th point and 5th point. He's saying the number of ways of selecting one or more questions from n questions where each question has an alternative, he's telling. It's also your axiometrical question and previous year question as well. Let me see, where can I find that? See. See this example. Yeah, Gita, now I hope that issue won't be there. Still the voice is breaking. Or is it fine? Due to heavy rain, little internet instability is there. I hope it shouldn't be there now. Okay. See here, I'm telling a paper has 6 questions, each having an alternative. Each having an alternative. I'm telling number of ways an examinee can answer one or more. That's a given question. A question paper has 6 questions, each having an alternative. The number of ways an examinee can answer one or more. Total 6 questions are question 1, question 2, question 3, question 4, question 5, question 6. Each question is having one or more alternative. Means in question 1, you can answer first alternative or second alternative. If you want, you can even leave the question also. So each question has 3 possibilities. Either you can answer first alternative or second alternative, or you can leave the sum. Okay, it's a question paper, right? I need to answer all the questions. So 3 into 3 into 3 into 3 into 3 into 3. Now what if I select everywhere this alternative of leaving? The basic purpose of the question will get violated. So I'm reducing one possibility. This one possibility is leaving all the questions. It's telling a paper has 6 questions, each having an alternative. The number of ways the examiner can answer, at least one or more, minimum one or more you have to answer. You can't leave all the questions. That's the reason I'm doing -1. -1 refers to probability of leaving all the sums. Okay. So 3 power 6 minus 1. So how much will get 3 power 6 minus 3, 2, 2, 3, 4, 5, 6, 729 minus 1, which is equals to 728. Okay. So I hope the question is, the concept is clear. 3 or more, this is how we will select it. Okay. Now 1 minute, that's PDF got downloaded. I'll check that question. To combinations, it's a very good question which you can try. So I hope there is no doubt in this sum. It's a simple one. It's a little lengthy question. I'll share it in your group. Once try it after the class. That's a very good one. When you're free, just try it after the class. Let me share it in the group. The question is little lengthy. In next World Cup, there will be 12 teams divided equally into 2 groups. Team of each group will play a match against other team of the group. From each group, 3 top teams will qualify for next round. In this round, each team will play against each other. 4 top teams of this round will qualify for semi-finals and play against each other. Top 2 teams will go to final. When they play best of 3, how many minimum number of matches will be held? It's a little lengthy question. It's a tricky question also. It was asked in June 2023. Okay, let's go ahead and try solving that sum. Okay, so I hope this concept is fine. So 3 power n minus 1, the number of ways of selecting one or more questions from n questions, where each question has an alternative. So it is simply equals to 3 power n minus 1. Next. He is telling NCR minus 1 plus NCR is equals to n plus 1 CR. Okay. So he's telling NCR plus NCR minus 1 is equals to n plus 1 CR. Now, how they'll be asking questions for you? I'm asking 500C92 plus 499 500C92 is equals to 499C92 plus NC91. Okay, 500C92 is equals to 499C92 plus NC91. I'm asking what is the value of n. So when these type of questions are given, just see the pattern. The pattern should be R minus 1. 92 minus 1 is 91. So pattern is perfect. These two must remain same. These two must remain same. So therefore, n will be equals to 499. Okay. So simple one, there is nothing much difficulty. You need not elaborate it and solve it. It's a straightforward solution. Once solve this and tell me the answer. Similar question related to this example. 12C5 plus 2 into 12C4 plus 12C3 is equals to 14CX. I want you to calculate the value of X. Think and solve. Similar parallel question, guys. 12C5 plus 12C4 plus 12C3 is equals to 14CX. Go ahead and calculate X. It's a simple one, just try it once. Perfect, Geeta. Okay, it's a 4 marks question IP. Okay. See here, it's a simple one. What is telling? What I'll do first, let's go ahead and elaborate it. 12C5 plus 2 into 12C4, I'll write it as 12C4 plus 12C4 plus 12C3. Okay. Now see what I said you should have in a format of R minus 1. R minus 1, R minus 1. Okay, then it will be N plus 1 CR. N plus 1, 13 plus 12 plus 1, 13, CR plus 12 plus 1, 13, CR. Next, again, can you see the format is R and R minus 1. This will be N. So, NCR plus NCR minus 1 is N plus 1 CR. So, 13 plus 1, 14, C5 is equals to 14 CX. Okay, what I said, if NCX is equals to NCY, either N will be, if NCX is equals to NCY, CX is equals to NCY, either X will be equals to Y, either X will be equals to 5 or X plus 5 will be equals to N. 5 plus X is equals to 14. So X will be equals to 14 minus 5, which is equals to 9. So answer will be 5 or 9. So X can be either 5 or X can be either 9. Okay. Simple one. It's nothing much difficulty over here. I hope you. There are 2-3 questions which I want to solve from ICA material. So let me solve them first. And then we'll proceed to the next questions. This one we have already solved. This also we have solved. Now see these 2 questions, 21 and 22. See here what is telling. Question number 21. It's an important one. Many times students will get confused in these questions. There's no point in getting confused. They're quite similar. So they're quite simple. 21st question. He's telling a Supreme Court has given 6-3 decisions. Now, what is the 6-3 decision? 6-3 decision means 6 people said yes 3 people said no. So total, how many people you have? Total 9 people you have. Upholding a lower court. The number of ways it can give a majority decision reversing the lower court. The number of ways it can give a majority decision reversing a lower court. Now see here, there are total 9 people. In these 9 people, if you want to form a majority people, how many people will form majority among 9 people? In 9 people, how many people form a majority? In 9 people, sir, 5 people will form a majority. Sir, 6 will also form a majority, or 7 will also form a majority, or 8 will also form a majority, or 9 will also form a majority. Okay, the Supreme Court has given 6-3 decision, means total 9 people are there. He's telling how many form a majority in this 9 people. There 5 is a majority, 6 is a majority, 7 is a majority, 8 is a majority, and 9 is a majority. How will you select 5 people from 9 people? 9C5 plus 9C6 plus 9C7 plus 9C8 plus 9C9. 9C9 is 1, 9C8 is 9. Let's check what these values will be. 9C5, 9 into 8 into 7 into 6 into 5. 126, 9C6, 84, 9C7, 36. Let's count. 126 plus 84 plus 36 plus 9 plus 1. So answer is 256. Okay. So I hope the concept is clear. 6-3 decision. How will you reverse it? Next. So answer is 256. Here's Geeta. He is telling a Supreme Court has given 6-3 decision. 6-3 decision means 6 people said yes, 3 people said no. Total there are 9 people upholding the lower court. The number of ways it can give majority decision reversing the lower court. He's telling from these 9 people, I have to select a majority people. Now from 9 people, is 1 person a majority in 9? No, sir. 1 by 9, it's not a majority. It's 2 people majority? No. 3 people majority? No. 4 people majority? No. 5 people is majority? Yes. From 9 people, I can clearly say that 5 people are majority. So 9C5, 6 people is also a majority, 7 is also a majority, 8 is also a majority, 9 is also a majority. So 9C5 plus 9C6 plus 9C7 plus 9C8 plus 9C9, which is equals to 256. I mean, I'm selecting majority people from 9 people. Means I'm telling major people I want. 5 people say yes, 4 people say no, it will be reversed. 6 people say yes, 3 people say no, it will be reversed. 7 people say yes, 2 people say no, it will be reversed. Okay, like this, majority people I'm selecting. Okay, next. 5 bulbs, out of which 3 are defective, means 2 are good, are to be tried in 2 bulb points in a dark room. The number of trials the room shall be lighted. I can keep 1 good bulb and 1 bad bulb. There will be light in a room. Or I can keep 2 good bulbs. There will be a light in a room. How will I select 1 good, 1 bad? 3 defective, 2 defective. From 2 good, I'll select 1 good. 2C1. From 3 defective, I'll select 1 defective. 3C1. Good and good. How will you select 2 good? From 2 good. 2C2. So 2 into 3, this is equals to 1. 2 into 3 is 6. 2C2 is 1. Total possibilities are 7. He's telling 5 bulbs, out of which 3 are defective, are to be tried in 2 bulb points in a dark room. Number of trials that can be made so that room shall be lightened. Either I can keep 1 good and 1 bad, or I can keep 2 good. Okay, so I hope the concept is clear. Yes. Next. 13th and 14th. Let's look into this 13th and 14th. At an election, there are 5 candidates. 3 members are to be elected. A voter is entitled to vote for any number of candidates not greater than number to be elected. The number of votes a voter can choose. 5 candidates are there and 3 members are to be elected. Okay. A voter is entitled to vote for any number of candidates. Means for 5 candidates, can a voter vote for 1 candidate? Yes, sir. Can a voter vote for 2 candidates? Yes, sir. Can a voter vote for 3 candidates? Yes, sir. Can a voter vote for 4 candidates? No, sir. Why he's telling he can vote not greater than number to be elected. Number to be elected is 3. So maximum he can give 3 votes. Can give either 1 vote or 2 votes or 3 votes. 5C1 is 5. 5C2 is 10. 5C3 is also 10. So answer is 25. Okay, basically you see in MLC election, this type of voting happens. In general election, 1 person will get 1 vote. But in MLC elections, it will be different. You can have 1 vote, 2 votes, or 3 votes also. Again and again, it's telling internet connection is unstable. Let's see. Every 2 persons shake hand with each other in a party, and total number of handshakes is 66. Now, how many people you require to make a handshake? Obviously, sir, I require 2 people to make a handshake. So NC2 is equals to 66. N into n minus 1 by 2 factorial is equals to 66. N into n minus 1. What is 66 into 2? 132. Okay. Now check with the options where you are getting 132. 12 into 11 is 132. So answer is option B. We require 2 people to make an handshake. So NC2 is equals to 66. Next. There is one very important question which I want to solve now. Listen carefully. This one. Question number 2. He gave you the word examination. He is asking number of ways of selecting 4 letters. Let him give the word examination. Let him give the word mathematics. Or let him give the word combination. For all these words, answer is same. The number of ways of selecting. The number of ways of selecting from the word examination. How many 4 letters, how many ways 4 letters can be selected from the word examination? So see here everybody. No, Geeta, that's not that simple. 11C4 is not the answer. How many E's you have? 1. How many X you have? 1. A are 2. M is 1. I is 2. N is 2. A is completed. T is 1. I is completed. O is 1. N is completed. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters are there in the word examination. I need to select 4 letters from the word examination. 3 cases are possible. Case 1. I can select all 4 different letters. How can you select all 4 different letters? How many different letters are there? 1, 2, 3, 4, 5, 6, 7, 8 unique letters or 8 different letters are there. So I'll select 4 letters from 8 letters. So what is 8C4? 8 into 7 into 6 into 5 divided by 24. 70 ways. This is case 1. I guess 136 will be the answer. all four different letters. All four unique letters I'll select in first case. Next, case 2. Two letters same, comma, two letters different. What do you mean by two letters same, two letters different? Like I'll select AAMI, or I'll select AAIN, or I'll select EXII. Means one pair I will select, two unique letters I'll select. Now, how many pairs you are having? This is a pair, pair, pair. From three pairs, I'll select one pair. 3C1. Now, one pair is completed. Any one pair you can cancel. Now, how many unique letters are left? 1, 2, 3, 4, 5, 6, 7 unique letters are left. 7C2. So 3C1 into 7C2. 7 into 6 divided by 2 into 3. 63 ways. This is 70 ways. This is 63 ways. Now case 3. Two same. Two same. Means I'll select it as AA, II. Or I'll select IA, AI. Or I'll select NN, AA. Means from three pairs, I'll select two pairs. This is one pair. This is one pair. So from three pairs, I'll select two pairs. Equals to 3. So 70 plus 63 plus 3. 136 ways are. Okay. So all four different letters, 8C4. Two letters same, two letters different. Two letters same means one pair. Two letters different means two unique letters. Two same, two same. So three cases are possible. First case, all four different. In second case, two letters same, two letters different. In third case, two same and two same. Total 136 ways. So there are 136 ways to select four letters from the word examination. Okay, sir. Okay, sir. You have said regarding selection. What about arrangement? Seventeen to four letters can interchange among themselves in 4 factorial ways. 63 into 4 letters can interchange among themselves in 4 factorial ways. But since two letters are same, I will divide by number of repetitions. 4 letters can interchange among themselves in 4 factorial ways. But since two letters and two letters are same, I'll divide by number of repetitions. So 70 into 4 factorial, which is 1680. So 63 into 24 by 2, 756. 3 into 24 divided by 80. 1680 plus 756 plus 8. So 2454 is the answer. The number of ways of selecting four letters from the word examination, mathematics combination, 136. The number of ways of arranging, 245. Okay. Little tricky one, but I hope you will be in a position to digest it. Now, in similar parlance, I want you people to solve one question. Think and solve. It's simple. I want you to solve this question number 13. Wait 1 minute. Yeah, question number 13. I'll give you 5 minutes time. Solve this 13 and tell me the answer. Yogita, you got 1 or 2. Yeah, 1 or 2 is also correct. Yes, 1 or 2 or 1 or 3, something you will get the answer. Let's check. Double one, double two, three, four. Double one, double two, three, four. What he's asking? He's asking you to find four-digit number. He's asking you to form four-digited number. One is repeated two times. Two is repeated two times. Three is repeated one time. Four is repeated one time. Same same three cases you'll have. Case one, case two, case three. Four different letters, different numbers. Two same, two different. Two same, two same. Now four different letters. How many unique letters you are having? Four unique letters you are having, right? 1, 2, 3, 4. How will you select four letters from four letters? 4C4, which is 1. Next, two same, two different. Means I will select one pair. Can you see two pairs you are having? How will you select one pair from two pairs? 2C1. Let us assume this pair is cancelled. How will you select two different letters from three different letters? 3C2, which is 6. 2C1 is 2, 3C1 is 3. 2C1 is 2, 3C2 is 3, so 3 into 2, 6. Two same, two same. From two pairs, I'll select two pairs, which is equals to 1. 2C2, which is equals to 1. This is selection. Now, four letters can interchange among themselves in 4 factorial ways. But since here there is a pair, I will divide by number of repetitions. Okay. Exactly same like previous question. But here instead of alphabets, we have numbers. 24 divided by 2 into 6, 72. 24 divided by 6. So 24 plus 72 plus 6. Answer is 102. Okay. Simple one. Nothing much difficulty over this question. Same as how many cases were there in the earlier one. Same number of cases we have here as well. Next. I hope Geeta and Vaishnavi, the point is clear. Now, see this question number 10 before proceeding further. Question number 10. The results of 8 matches are to be predicted. The number of different forecasts containing exactly 6 correct results. Eight matches are there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. In this, 6 matches have correct result. In 6 matches, there will be a win. Do you know what are the 6 matches for which there is a win? No. So for these 8 matches, I'll select 6 matches which has win 8C6. Win, 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 and win. 6 matches you will win. Next 2 matches either can be a loss or draw. Loss or draw. Means for this match there is a 2 possibilities. For this match there is a 2 possibilities. So 8C6 into 2 into 2. So answer is 102. Okay. So I hope the point is clear. 8 matches are there, in which 6 are correct. For which 6 will be correct win, I don't know. So I'll select 8C6. 2 matches can be loss draw, loss draw. 8C6 into 2 into 2, which is 102. Okay. So I hope question number 10 is clear. third and fourth. The number of different words that can be formed from 12 consonants and 5 vowels by taking 4 consonants and 3 vowels in each time. First, from 12 consonants, I'll select 4 consonants. 12C4. From 5 vowels, I will select 3 vowels. 5C3. It is a word, right? In word, arrangement matters. So total 7 letters are there. 4 plus 3 is 7. Those 7 letters can interchange among themselves in 7 factorial ways. So answer is 4950 into 7 factorial. Next, 12C4 into 5C3 is 4950. 8 guests have to be seated. 8 guests, question number 4. 8 guests have to be seated, 4 on each side on a long rectangular table. 4 on each side on a long rectangular table. 2 particular guests, particular means we know who are those people. 2 particular guests decide to sit on one side. 2 particular guests decide to sit on one side. Next, 3 on other sides. There are 3 particular guests who will decide to sit on other side. So how many are left? 8 minus 2, 8 minus 3. 5 are, 3 are left. The number of ways in which seating arrangement can be done. Now see here, in total 8 seats, 5 seats got placed, right? From 3 gens, I'll select 2 gens to sit here. Okay. From 3 guests, I'll select 2 guests to sit here. So these 2 are also filled. 1 guest is left. I'll ask this 1 guest, go and sit here. Now 4 people here can interchange in 4 factorial ways. 4 people here can interchange in 4 factorial ways. So 3 into 4 factorial 24, 4 factorial 24. 1728. 1728. Okay. 8 guests are there. 2 people will sit on one side. So tell them to go and sit there. Another 3 people will sit on other side. So let them go and sit there. Okay. Now, from 8 places, 5 are completed, 3 are left. Okay, and 3 guests are left. First, I'll select 2 and make them sit down. 1 person will go and sit up. So 3C2 into 1C. 4 members can interchange 4 factorial. Up 4 members can interchange 4 factorial. Final answer is 1728. Simple, nothing much difficulty. Yes, sir, nothing much difficulty. Now, let's go for the next one. All these we have already solved. 14, 15. Let us get back to our notes. So number of handshakes, NC2. Number of gifts, if each person gives a gift to each other, please remember it, it is NP2. Number of handshakes is NC2. Number of gifts are NP2, and number of railway stations in N railway stations is also NP2. Means if you want to issue a ticket, you need to take 2 railway stations, right? You will select it, sorry, you will arrange it in NP2, means going and coming, you can interchange it. Next. So handshakes NC2, gift NP2, railway station also NP2. Selection of 4 letters from the word combination. Mathematics examination 136. Arrangement 2456. Selection we have done, arrangement we have done. Next factors. Next we are having geometrical applications. Now let's look into geometrical applications. Now number of diagonals in a polygon n into n minus 3 by 2. Okay. Now there's a logic also behind this formula. I'll let you know that. Number of diagonals in a polygon. Say for example, you are having a pentagon. Pentagon. Let's take a nanogon. Nanogon, how many sides it has? 9 sides it has. Nanogon has total 9 sides. How many diagonals can be formed? 9 into 9 minus 3 by 2. So 9 into 6 whole divided by 2. Total 27 diagonals can be formed. I hope you know what is diagonal. Say for example, I'm having a rectangle which has 4 sides. How many diagonals are possible? 2 diagonals are possible. Okay. So for a rectangle or for a quadrilateral which has 4 sides, 4 into 4 minus 3 by 2. 4 into 1 by 2, which is equals to 2 diagonals are possible. 2 diagonals are possible. A square, quadrilateral, basically, 2 diagonals are possible. So I hope the first geometrical application is clear, right? Simple geometrical application.